Okay, in this video we're going to look at Kw, which is the water constant. So as we learned in our equilibrium unit, the equilibrium constant for anything is Keq equals the concentration of the products divided by the concentration of the reactants. So when we're deriving Kw, or our water constant, it's the same thing as finding an equilibrium constant for the dissociation of water into its hydrogen ions and hydroxide ions. So let's take a look at what that would look like if we found the equilibrium constant for the dissociation of water. And we're going to set it equal to Kw because we know when we're finding the equilibrium constant of water, we write it as Kw. So it's equal to our concentrations of our products, our products. I'm going to multiply them together. So H plus times OH minus divided by the concentration of our reactants. But in this case, because our water is actually in the liquid form, we aren't going to include it in our equation. So what our Kw would actually look like is simply H plus, our hydrogen concentration, times our OH minus concentration. And because it's a constant, we know that Kw is always equal to 1 times 10 to the negative 14. So how we use that? We can use it for this to solve this equation here. So what is the H plus concentration if 0.01 molar hydrochloric acid dissolves in water? And what is the OH minus? What is the hydroxide concentration? So, first of all, we can only use Kw to solve for our hydrogen ion or our hydroxide ion concentrations if we're dealing with a strong acid and a strong base. We need it to dissociate completely because we need to be able to predict that 100% of our acid or our base is going to dissociate into its ions. So since we're dealing with HCl, we know that it is a strong acid, so we can use Kw to solve for our hydrogen ion concentration and our OH ion concentration. So our equation is actually going to look like this. HCl, and again one arrow because it's a strong acid, so it's going to dissociate completely into hydrogen and Cl minus. So our hydrochloric acid concentration is 0.01 molar. So because it's going to dissociate completely, I know I'm also going to have 0.01 molar hydrogen ions and 0.01 molar of my chlorine ions. So my H plus concentration is simply equal to 0.01 molar. But they also want to know what the OH concentration is. Well, we know from our Kw, from our water constant, that 1 times 10 to the negative 14 is equal to H plus, our hydrogen ion concentration, times our hydroxide ion concentration. So we can use that, since now we have our hydrogen ion concentration, we can use our Kw constant formula to find our concentration of our hydroxide ions. So if we set it up, we get 1 times 10 to the negative 14, because that's Kw, equals the concentration of our hydrogen, which is our hydrogen ion, 0.01, times the concentration of our OH minus. Make this a little bit smaller so we can continue. So now all I have to do is 1 times 10 to the negative 14 divided by 0.01. And if I plug that into my calculator, I get 1 times 10 to the negative 12. Because another way of writing this is actually 1 times 10 to the negative 2. And 14 minus 2 equals 12. Because remember, when you're dividing things in scientific notation, you're going to subtract the exponents. You can kind of ignore the negative signs and just subtract the exponents. If you're multiplying things in scientific notation, you're going to add the exponents. So 1 times 10 to the negative 12 is equal to our OH minus concentration. And that's how you can use how you can derive your Kw, your water constant, and use it to figure out either your hydrogen ion concentration or your hydroxide ion concentration when you're dealing with a strong acid or a strong base that's going to dissociate completely.